All right, welcome back, everybody. We're going to go over the next section 3.3, which is characteristics of polynomials when they're in factored form. So we know that polynomials, quadratics, can be written in standard form and factored form. And we know that factored form looks like a whole bunch of brackets, right? A whole bunch of factors. Depending on the degree, that would be how many brackets we could potentially have. So, just to start things off, we remember from what we did before of finding out x-intercepts. When we find out x-intercepts, what we do is we figure out what value of x will make each of these factors 0. So the first one would be -7, because -7 plus 7 is 0. The second one that we have here would be -4, because -4 plus 4 is equal to 0. And the last one that we have over here, x is equal to 5, because 5 take away 5 is 0. So I would have x-intercepts at -7 on my graph. I would have one at -4 on my graph, and I would have one at 5 on my graph. Same goes for the second example that we have over here on the right. This one has multiple factors as well, so we want to figure out which value of x makes each of these factors 0. So we have this -2 out front. There is no value of x that would make this factor 0 because it's just -2, it's a constant. But we do have a second factor here, the bracket. A value of -3 would make that 0. We have x minus 2. An x value of +2 would make it 0. And then the last one that we have over here, its x-intercept would end up being at 5/2, or 2.5. And if you say, well, how did he get that? Remember how we get x-intercepts? We basically take our bracket and we set it equal to 0. And we isolate for x. We add 5 to both sides. And then divide by 2, and that's where we get that 5/2. Oops. Now, if we continue on, what we want to do is look at the graphs and see what's important when we have our x-intercepts and how it relates to our equation. So, if we look at this first equation here, we see that there are two x-intercepts. There's one here at -2, and there's one here at +4. We might realize that each of these x-intercepts is attributed to one of these two factors, but they act differently at both of those x-intercepts. The one on the left goes up to the x-intercept, touches the x-axis at -2, and then turns around and comes back down, whereas the one on the right passes right through. The reason why is because if we zoom in on our graph, on our x-intercept, and we see what's happening around our x-intercept, we see that our graph goes up and comes down. You say, well, what does that orange graph look like? Well, the orange graph looks like a quadratic to me. The one over here on the right passes right through. Looks similar to a linear equation to me. Passes right through. And that's going to give us information about our equation and the order of each of our x-intercepts. And when we say order, I'm talking about the exponent that appears on each of our x-intercepts. The x plus 2 is squared, which means that x plus 2 x-intercept or factor has an order of 2, and the x minus 4 has an order of 1. That will give us information about how the equation appears, or the graph appears, around that x-intercept. Degree of 2 is a quadratic, so it's going to act like a quadratic around that x-intercept, as we see here. Degree of 1 is a linear equation. It's going to act like a linear equation as it passes through that x-intercept. And that's always going to be true. We'll look at a few more examples here. This one here has x-intercepts at, I'll zoom in a bit, at -2, has an x-intercept at 1, and also has one at 3. And if we figure out which parts of the equation are attributed to each of them, x plus 2 x-intercept there, x plus 1 x-intercept here, and +3. And if I look at the order on each of them, that's going to give me information on how the graph acts at that x-intercept. So the x plus 2 has an order of 1, so it should act like a linear equation and pass right through. X minus 1 has an order of 1, so it should pass right through as well. X minus 3 has an order of 2, so it should act like a quadratic, and you can see that it does act like a quadratic at that x-intercept. So look at a couple more examples here. These ones here only have two x-intercepts, one of them at -2, one of them at 1.5. Both of them have a degree of order of 2, so it should act like a quadratic at both of those x-intercepts. Now you're probably getting the idea now, but I'll look at a few more here. What happens if we have degree of 3? Well, it's going to act like a cube function. We know that cube functions act like they have a twist. So we have one at -4 for an x-intercept and one at +1. For the x plus 4, it should act like a twist, so it's going to flatten out around the x-intercept but still pass through. And the x minus 1 factor has an order of 1, so it should pass through like a linear equation. Same goes for these. X minus 1 has a square on it, so it should act like a quadratic. X minus 5 has a cube on it, so it should act like a cubic function as it passes through. And finally, the last one that we have over here. For our equation, you have to remember that each of our x-intercepts, we have one at 0, we have one at 3, and we have one at -2. So now in this case, the circle kind of gets in the way a little bit there, but for the x-intercept that's created from the first term, well, that has a degree of 1. There's no exponent on this, just 1. So for the x-intercept at 0, it should pass through like a linear equation. It's going to pass straight through, like so. For the x minus 3, it has a degree of 1 as well, so it's going to pass through like a linear equation. But the x plus 2 is cubed, so it should act like a cubic function. So it comes down, passes through, and continues down. It has to turn around afterwards to come back up to the x-intercept, but it does act like a cube function, a twist over there on the left side. Alright, so we're going to use this information in order to graph some of these or sketch some of these. On the next page at the top, it just goes over that order stuff that I was talking about. Basically, it's the exponent that would appear on any one of our factors, and it gives us information about how the equation is going to act around those x-intercepts. So when we want to sketch these, we're going to take this one over here on the left first. And what's important is, first let's find our x-intercepts. Our x-intercepts happen when each of these factors is 0. So the -0.5 doesn't give us any values for the x-intercept because there's no x there. The first factor there of x plus 1 tells us we have an x-intercept at -1. The second factor tells we have an x-intercept at -3. And the third one gives us information that there's an x-intercept at +2. Some other important information that we're going to need here is the degree. Now the degree is going to be the highest exponent we have when we multiply all of our x's through. So one thing that we might pay attention to, or one thing that we can pay attention to is if we have a degree of 1 here, a degree of 1 here, and this second one is x minus 2 squared. If we expanded that out, the biggest exponent we'd have is x to the power of 2. So when we're multiplying, the biggest exponent is going to be what happens when we multiply all the x's together. So if I multiplied x1 times x1, I'll get x squared, and multiply that by x2, we're going to get x to the power of 4. So that means our degree is 4. We can get that just by adding up all the orders of our equation as well, which would be 2, 1, and 1. There's no x on the first terms, which is also 4. So our leading degree is 4, which is an even degree, which tells me that the end behaves. So another important piece of information is the leading coefficient when we're sketching. So the leading coefficient can be found if we expanded this entire polynomial out, but we wouldn't have to. What we would have to do is just figure out what would be the coefficient on the x4 term, x to the power of 4. So in order to get that, what we would really have to do is just multiply our value out front by the coefficient on x here, by the coefficient on x here, and the coefficient on x here, which are all 1. So it would be -0.5 times 1 times 1 times 1, which is also -0.5. And lastly, what we can do is find our y-intercept, because our y-intercept is going to give us some good information as well. So the y-intercept is, if you remember, whatever the output is when I put in x is 0. So in factored form, it's a little bit different. It doesn't just eliminate all the terms. So what I can do is, imagine if I put in x is 0, we'd still have that negative 0.5 out front. The first bracket, if I put in 0, will be 1. The second bracket will be 3. And if I put in 0, the last bracket is going to be 0 take away 2, which is negative 2, squared, which is 4. And if I multiply all those values through, we're going to end up with negative 6. That means we have a y-intercept at negative 6. And what we can do is put all that information onto our graph down below. So first I'm going to put on our x-intercepts at negative 1, negative 3, and 2. So if I zoom in, negative 1, negative 3, positive 2. We also know that we have an even degree, so the end behavior should be on the same side. And we also know that the leading coefficient is negative, so that means it's been reflected. So that means that our graph is going to have to start from the bottom and end on the bottom. That's all that we really know so far. I don't know how it's acting in between, but I know it's going to touch those x-intercepts. I know that we have a y-intercept of negative 6, so I can put that on my graph here as well. So if I count 6 down, 1, 2, 3, 4, 5, 6. And then all I have to do is figure out how my graph is going to act at each of these x-intercepts. So the one that we have on the very far left is at negative 3. And from our equation, that has an order of 1. So it's going to pass right through that one like a linear equation. So I'm going to draw this one. I'm going to continue it through. And it's going to pass right through. The next intercept that we have was the one that was created from negative 1. And that one also has a degree of 1. So I know that my graph's going to have to pass through that x-intercept. Now for the maximum, local minimum for now, we're just going to do a turn. We'll be calculating that a little bit later on. I know that my graph's going to have to touch that y-intercept way down at negative 6, but what I'm also interested in what happens at that x-intercept over on the right, where x is equal to 2. That one had an order of 2, if you remember, up at the top. So that means it's going to act like a quadratic when it touches that x-intercept. So I'm going to take this graph. It's going to come down, touch here. I don't know where it's going to turn around, but I do know that when it gets back up to this x-intercept, it's going to touch it and continue down. So our graph will look something like that, not exact, but we do know how it's going to act at those x-intercepts, and we do know both of the end behaviors should be at the bottom because it's an even function, which means the end behavior should be on the same side, either top, top, or bottom, bottom. But the fact that it's a negative leading coefficient tells me that it's going to be from the bottom to the bottom, just like a negative leading coefficient, or a value for quadratics. It was started on the bottom left and ended on the bottom right. We'll do the same thing over here on the right. I'll get you to try one. If you want to give it a shot, you can pause it, obviously. But this one over here, this one is not in factored form. So what we would have to do is factor this. So if I look at this, the easiest way is to just notice that both of them have an x term. They both have x squared. They both have x to the power of 3. So I can factor out x cubed. That'll leave me with x plus 2. And I can find my x-intercepts from these. My x-intercepts are created by whichever values of x makes each of these factors 0. So over here, it'll be 0. For this one, will be negative 2. Oops. So the x-intercept of 0 has an order of 3, so it should act like a twist, a cubic function at that spot. And the x-intercept of negative 2 should act like a linear equation because it has an order of 1. A couple other pieces of information that are important would be the degree. In this case, I would look up at the top equation because that one's already in standard form. And I would see that the degree is 4. My leading coefficient, well, I can look at the standard form equation too. I see x to the power of 4. Well, that has a leading coefficient of 1, so that's positive. And then finally, my y-intercept, if I plug in 0 for each of those terms, I can put it into either standard form or factored form. Standard form is easiest because all the terms that have x will become 0, and we have a y-intercept at 0. So that's enough information for us to graph it. We do know that the degree is even, so the end behavior should be on the same side. I know that the leading coefficient is 1, so it has not been reflected. So I do know that the graph is going to be on the same side, but start at the top and end at the top. So if I'm to sketch this graph out, zoom out a little bit here, I know that my graph is going to start from this side. I know it's going to end at this side. We'll figure out what happens in between by all the characteristics that we figured out. We do know we have an x-intercept at 0 and -2. So I'm going to put those on here. I do know that we have a y-intercept of 0, and that's the same as the x-intercept of 0. It's already on our graph. And finally, what we're going to look at is the order of what's happening to each of our graph at each of these spots. So I know that the x-intercept of 0 has an order of 3. I know that the x-intercept of -2 has an order of 1. So the x-intercept of -2 should pass through like a linear equation. So it's going to come down, it's going to pass right through. Then it's going to come back up to the x-intercept that we have at the top, and since it has an order of 3, we're going to have it pass through like a cube function, which has a little bit of a twist. So if I continue this one through, it's going to come through, it's going to flatten out, and it's going to take off again. Fix that a little bit. It's going to come up, it's going to turn, and then it's going to take off. Something along those lines. But that's a general idea of what the functions look like. That's just the sketch of those functions that we have at the top. You can try those ones on your own. There's some in the homework as well if you want to give it a shot. So it is the last thing that we have to do is the opposite. So in this equation, what we did was we took the equation and we made a sketch from it. The last thing that we have to do is we take the sketch and we see if we can come up with an equation from it. That's what we're going to look at here. So this one here says, write the equation of a cube function. So that means it has a degree of 3. That has zeros or x-intercepts at -2, 3, and 2 over 5. And it has a y-intercept of 6. So that's going to be some important information for us. Very similar to what we did back with quadratics in grade 10. Is, well, if they have x-intercepts at -2, 3, and 5 over 2, I know that I can write the equation as being x plus 2, x minus 3, and 5x minus 2, or you can have x minus 2 over 5. And that's g of x or f of x is equal to whatever. The idea is we don't know what the value is out front, our a value. But you'll remember back from grade 10 that we could figure that out by taking our point that we know, our y-intercept, which is a point of 0 and 6, says, well, x is 0, y is 6, or g of x is 6 in this case, and we can substitute it in and try to isolate for a. And that's all that we need to do. So what I'm going to do is I'm going to take that equation that we have at the top and just substitute in that point to figure out what our a value is, because that would be a function that would pass through a y-intercept of 6. So if y is equal to 6 is equal to a. Our first bracket, well, if x is 0, it's going to be 2. Second bracket, if x is 0, is going to be 3. And our third bracket over here, if x is 0, is going to be -2. And as I work my way through, I'm going to multiply all these numbers together. So 2 times -3 times -2 is positive 12. And I divide both sides by 12, and I get a is equal to 6 over 12, or a half. So I know what that leading value is going to be. From there, I know what the equation is going to be, because now I have all the information that we want. I know that g of x is equal to that a that's out front, which is a half, and then all of my factors. X plus 2, x minus 3, and 5x minus 2. We have our equation. We wrote it out. That will pass through the y-intercept of 6 and has x-intercepts at -2, 3, and 2 over 5. And apply that same idea to a graph for the next one that's down below. You can give it a shot, as I said. At any time you can pause it and try yourself, but I'll just continue along. But in this case, if we look at our graph that we have over here, I notice that we have an x-intercept here at -2, and we have an x-intercept over here at 3. So I do know that part of our equation is going to be x plus 2 and x minus 3. Oops. We also look at what's happening at those x-intercepts. If you ask me to look at both of those ones, they look like they act like a quadratic around both of those x-intercepts. So that would mean that both of these should have a degree of 2. In this case, we'll have f of x is equal to. We always have that a out front of factored form. Could be 1, we don't know. But one thing that I do know is that we know a point that it passes through. We know it passes through 2 and 4. I know that when x is 2, y is 4. So what I'm going to do is I'm going to substitute in y is 4 and x is 2. So if we have 4 here, we have our a value. If x is 2, the first bracket will be 2 plus 2, which is 4. 4 squared is 16. For the second bracket, we'll have 2 take away 3, which is -1. -1 squared is +1. And as I multiply those ones on the right side, we're going to have 16a. I'm going to divide both sides by 16. We're going to get a is equal to 4 over 16, or 1/4. From there, now I know I can write the equation of that graph that we have over there on the right, because I have that a value. We know f of x is equal to a, which is 1/4. We have x plus 2 squared, because it acts like a quadratic. And the other x-intercept was at x minus 3. And it also acts like a quadratic, can be squared. And that's it. So for today, what we went through, we started with an equation, we came up with a sketch, and we can do the opposite. We can start with a sketch and go back to the equation. At the bottom of the page, there's some practice questions that normally I would have given to you, but you can give a shot on some of these ones, especially the ones at the very beginning.